lesson 13, part B, area of an isosceles triangle.
Black.
I have a black.
Orange.
Orange? Okay, so area of an isosceles triangle. Either from your memory or from your formula sheet, how do we find the area of the triangle?
Base times height.
Base times height?
Divided by 2.
Yes, divided by 2. Okay, or the other way you could say this, if you move the 2 on the bottom out, you can factor it out as 1/2 times the base times the height. Same thing, just two slightly different forms. You can do whichever way works better for you. So either way. All right, now if we have an isosceles triangle, isosceles meaning, what does the word isosceles tell us? Anybody? Okay.
Two sides are the same length and one side is a different length?
You were correct until you said that last part. To be an isosceles triangle, two sides have to have the same length. The third one is usually different, but it doesn't have to be different. So technically, an equilateral triangle is also an isosceles triangle. But to be an isosceles triangle, the minimum requirement is that two sides have to have the same length. And the way we usually write that, isosceles triangle, same legs is what that means. And it means that two sides have the same length. Have same, that's M, length. All right. And usually we draw isosceles triangles with the congruent sides on the sides, and then the other, whatever the third leg is on the bottom. And so a lot of times what happens is, if we need to, let me make this a little bit bigger. So let's take a triangle. Those are supposed to be the same length. And let's say that this triangle, that this side has a length of 5, this side has a length of 5, and this side has a length of 4. This is an isosceles triangle because at least two sides, these two, have the same length. All right? Now, if we want to find the area of this triangle, what do we need to know to find the area of the triangle? We need two things. We need to know the base, and we need to know the height. What's the base on this one? Anybody? 4. Right? Base on the bottom is 4. So that part's easy. What's the height? It's not 5. We need to know the height. The height is going to be,
That's a good question.
Right here. Right? So there's the height. That's an H. There's the height.
Would the height be 6?
You get 6.
No.
4.
Just that?
Well, you can divide 4 by 2 to get the length of, actually.
Oh, yeah.
We do need to do that.
Yeah.
If this, I'm going to lose a cap here. All right, if this is 4, and these two sides are equal, and we find the height here, what happens is this cuts the triangle in half. So if this is 4, this distance from here to here is 2, which we do need to know because
We need to know the height.
yeah, we're going to use the Pythagorean Theorem to find the height. So now if we take a look at what we've done here, we cut that triangle in half.
Round 1.
We cut this triangle in half so that this side is still the 5. This side down here for the half triangle is 2, but now we have a right angle here, so it's a right triangle. This is the height that we're looking for, and because it's a right triangle, the Pythagorean theorem applies. We can use the Pythagorean theorem. Remember, the long side is the 5, so we've got the 5. Long side squared equals the sum of the squares of the other two sides. The other two sides being 2 and h. All right, so at least by cutting this in half this way, we make a right triangle that gives us two pieces of information. One that is the same as what they gave us, and the other one that we figured out just by dividing this in half. And a relationship between those that gives the height. So there we have an equation we can actually use. So let's do this. 2 squared is 4. H squared, we just have to leave as h squared for now. 5 squared is 25. Solve this for h. We've got h squared plus 4, so we've got to subtract 4 from both sides. That cancels, and we've got h squared equals 21, square root of both sides, and h is the square root of 21. We could do this on the calculator, but this is Algebra 2, and we are practicing how to keep radicals as radicals and work with them like that. All right. So now we have the height. Now we can come back to our formula and find the area of this triangle. We're looking for the area of this triangle, and the formula is base, which is what?
4.
4 or 2?
2.
4.
2.
On these problems, that's one of the most common mistakes, is you do have to cut it in half to find the height, but you have to remember that when you're answering the question, we're talking about this triangle, so you have to use the original base, the whole distance here. So we have a base of 4, a height of, we just figured out the height is radical 21, and for the formula, it's base times height divided by 2. So there we've plugged everything in, and now we simplify. 4 and the 2 is going to simplify to 2, and so we've got 2 radical 21. We can't simplify that anymore. And let's see, where there are units on this. This is example 13.4. It says that the dimensions are in centimeters. So the area is going to be in centimeters squared. Okay. So that's the procedure here. So for a recap, so to find for area of an isosceles triangle, you need to cut in half to make a right triangle. It looks like this. And then use Pythagorean Theorem to find height. To find height, you should write this down in your notes, by the way. Use Pythagorean Theorem to find the height, and then calculate the area. Make sure that you use the correct base. Oh, also in the Pythagorean Theorem, pay attention to where your variable is, because your variable is on this side, it's not on the other side. Okay? So here's our steps on how to find the area of an isosceles triangle. Cut it in half to make a right triangle, use Pythagorean Theorem to find the height, and then calculate the area. Let's do one more example. Say we've got 3, 3, and 4. I'm going to need the height. Cut it in half. So in my half triangle, and notice I drew this separately. It will help your work. It'll help your thinking to draw it separately. What's this side?
That side is 3.
Still the 3. What's the base of this one?
2.
2. So it's half of that. Okay, and here's our height. So our Pythagorean relationship, we've got the two sides, 2 squared plus h squared equals the hypotenuse squared. 4 plus h squared equals 9. Subtract 4 from both sides. Square root of both sides, and the height is going to be square root of 5. All right, so I use the Pythagorean theorem to find the height. Now I'm going to calculate the area, but remember it's the area of this triangle. And so the area is the base, which is 4, times the height, which I just figured out is square root of 5, and divide by 2, because that's where the area, or that's the way you find
So then
the
it's
formula.
2 radical 5. And then, oh, never mind.
And so yeah, so then that reduces, or cancels, and so we've got 2 rad 5, and whatever the units are. This was one of the practice problems that said dimensions are in meters, and so the area is going to be in meters squared. Okay. Okay, Drew, why don't you hit the stop button on the video, please?